Cynognathus was a heavily built animal, and measured around 2 meters in total length. It had a particularly large head, up to 40 centimeters in length, with wide jaws and sharp teeth. Its hind limbs were placed directly beneath the body, but the forelimbs sprawled outwards in a more reptilian fashion. This form of double gait is also found in some primitive mammals alive today. The dentary was equipped with differentiated teeth that show this animal could effectively process its food before swallowing. The presence of a secondary palate in the mouth indicates that Cynognathus would have been able to breathe and swallow simultaneously. The possible lack of belly ribs, in the stomach region, suggests the presence of an efficient diaphragm, an important muscle for mammalian breathing. Pits and canals on the bone of the snout indicate concentrations of nerves and blood vessels. In mammals, such structures allow hairs to be used as sensory organs. Diademodon lived right in the wake of the extinction during the early and middle Triassic, about 251 to 242 million years ago. Around 2 meters long, it was one of the largest known cynodonts, and it must have been a fairly successful species since it ranged across a large chunk of Pangaea, known from modern southern Africa, South America and Antarctica. It had pig-like cheekbones and enormous jaw muscles, along with sharp incisors and canine teeth at the front of its jaws and grinding molars at the back. For a long time, it was thought to be herbivorous, but evidence suggests it may have been omnivorous, with no clear conclusion on its diet. Its teeth were counterintuitive, with pronounced canines and postcanines adapted for vegetation. Stable light isotope analysis of oxygen from its fossils indicates reliance on water from streams, rivers, lakes, and snowmelt. These findings suggest Diademodon preferred habitats with much canopy cover and cooler environments. Another hypothesis was that Diademodon exhibited hippo-like behavior, staying in water during the day and foraging at night, but it lacked morphological or isotopic adaptations for long-term aquatic life. It may have lived near water sources and fed on shallow water seaweed, which has lower oxygen content. Cranial bones of Cricodon recovered from the manda beds include a crushed orbitoethmoidal region, a completely right mandible, fragments of the left mandible, loose teeth, and part of the occiput. The upper jaw's preserved parts include the posterior ends of the maxillae, a portion of the palate, and the floor of the orbits, with transversely ovate postcanines featuring 3 main cusps and small peripheral cuspules. The mandible has a sharp angle at the dentary and dental symphysis junction, and its postcanines are squarer than the maxillary ones. Each root in the Gomphidont cynodont's teeth is surrounded by cancellous bone, with the mandibular postcanines having a maximum transverse diameter of 1 centimeter. Impotens was one of the largest and non-mammalian cynodonts, with a skull well over 40 centimeters long. It was described as a new species in 2021, with the Antarctic specimen and a less complete specimen from South Africa being referred to the species. Impotens was probably the apex predator of its environment, as the only other large predator known to have coexisted with it was the somewhat smaller cynodont Cynognathus. The known large herbivores of the fauna are the cynodont Diademodon and the Dicynodont Euphiacyclops. The Cricodon Euphiacyclops subzone was deposited in a meandering river environment, with a deep channel and high banks. Both it and the Freemouth Formation were high paleolatitude environments, which may explain some of the faunal differences between them and lower paleolatitude fauna. Massatognathus was the smaller, plant-eating equivalent of the better-known Cynognathus with incisors, fang-like canines and flat-topped molars covered by low ridges, an adaptation for grinding tough plant stems, roots, and other plant materials. It had a low and flattened skull indicating that the specimen had a relatively shorter and broader snout than larger specimens. It was a fox-sized animal with claws on its feet and a long dog-like tail. It has been established that Massatognathus with multicuspate post-canines adapted to herbivory, moved the lower jaw posteriorly and dorsally during the power stroke of the occlusion. It is the only cynodont from the Chinares formation with clear adaptations for herbivory, with basand, labiolingually expanded upper and lower postcanines, ensuring a rudimentary dental occlusion, feeding on ground-level vegetation or on the lower branches of taller plants and shrubs. Menodon was unique among non-mammalian synapsids for the presence of hypsodont postcanine teeth. Hypsodont teeth grow continuously to counteract high wear caused by a diet of abrasive plant material. Menodon's teeth convergently resemble those of hypsodont xenarthrans such as sloths and armadillos, due to their column-like form and dentine which grows from the crown towards the root. Traversodonts are members of Gomphodontia, a group of herbivorous Cynognathian cynodonts. As an adaptation toward eating plants, they have wide postcanine teeth behind large canines. These postcanines are closely spaced with their crowns touching each other. Each is usually wider than it is long and is covered in several cusps. Because of their complexity, postcanine teeth are the primary means of identifying and distinguishing different species of traversodonts. Traversodonts have relatively short skulls. The snout is much narrower than the back of the skull. The tip of the snout is wider than the middle, as it constricts behind the large canines. The tooth rows of the upper jaws are inset while the maxillae and zygomatic arches extend outward, suggesting that traversodonts may have had cheeks. Primitive features of traversodonts include costal plates around the vertebrae, which stabilize the spine. These plates were lost in more advanced traversodonts like Exoretodon. While most traversodonts were relatively large cynodonts, particularly Cynognathia with extrapolated 60 cm skull making it potentially the largest non-mammalian cynodont, some late Triassic European forms like Mabugia and Habaya were very small. These traversodonts lived during the Rhaetian stage of the latest Triassic when rising sea levels divided Western Europe into an island archipelago. Traversodontids on these islands likely became smaller as a result of insular dwarfism. Exoretodon was an herbivore up to 1.8 meters long, with a specialized grinding action when feeding. An analysis of the size of the bones of calves collected in Paleorota concluded that the mother Exoretodon had 1 or 2 calves, for one pregnancy. Until recently, the Traversodontidae has been considered a clade of likely exclusive herbivores, although the discovery of Ajoia dentatransitus as one of the earliest diverging traversodontids suggests omnivory as a possible plesiomorphic condition for the clade. By interpreting young Exoretodon as an omnivorous traversodontid, it would follow that omnivory may not have occurred within the Gomphodontosuchini, but as a heterochronic shift toward larger body size in neonates. Additional analyses of ontogeny in traversodontids will be critical to assess if faunivory in young individuals is consistent across the entire clade, or if Exoretodon represents a relatively slow development, in which masticatory modification occurs postnatally. Regardless, the inclusion of animal material in diets amongst well-nested herbivores indicates a need to re-evaluate the evolution of herbivory across the Traversodontidae, and how differing developmental strategies are associated with ecological differentiation. Probainognathia is one of the 2 major subgroups of the clade Eucynodontia, the other being Cynognathia. The earliest forms were carnivorous and insectivorous, though some groups eventually also evolved herbivorous diets. Therioherpeton is an extinct genus of small, carnivorous cynodonts which lived in what is now Brazil during the late Triassic. Its type species is Therioherpeton cardnini. It was named in 1975 by the paleontologists José Bonaparte and Mario Costa Barberina. Eliodon's dentition is its most distinguishing morphological feature, with 3 distinct regions in the postcanine row. These regions are similar to the well-known Gomphodont, Diademodon tetragonus, leading to initial beliefs of Eliodon's inclusion in Gomphodonta. Aleodon uniquely has two lower jaw incisors and a long secondary palate, leading to its reclassification to Probainognathia. The presence of well-developed lingual singular platforms on post-canines led to some researchers excluding Aleodon from Cynognathia. The lingual singular platform is the most developed among all Triassic Probainognathians, suggesting a gradual development in Aleodon and Candelariodon. The skull of Cynognathia was larger relative to the body, but the brain remained quite small. The lateral temporal fenestra took up more than half the area of the skull in dorsal view. They housed very powerful jaw muscles. The brain case was ossified. The dentary extended above the cheekbone and the remaining jaw bones continued shrinking. A groove at the rear of the cheekbones may have held an ear canal leading toward the eardrum. The torso was shorter than in prior taxa. The tail was shorter and slenderer. Cynognathia had a very small, slender scapula. The hind limbs moved parasagittally, like a mammal, rather than laterally, like a more primitive reptile. The calcaneum extended posteriorly, forming a heel upon which the Achilles tendon inserted. This would have provided more spring to each step. The fibula had a sesamoid that fuses to the fibula in Ornithorhynchus. Probainognathus is an extinct genus of cynodonts that lived around 235 to 221 million years ago, during the late Triassic in what is now Argentina. It was a relatively small, carnivorous or insectivorous cynodont. Like all cynodonts, it was a relative of mammals, and it possessed several mammal-like features. Like some other cynodonts, Probainognathus had a double jaw joint, which not only included the quadrate and articular bones like in more basal synapsids, but also the squamosal and surangular bones. A joint between the dentary and squamosal bones, as seen in modern mammals, was however absent in Probainognathus. Based on an endocranial cast of ectoninian, several details have been extrapolated about its brain. Its cerebral hemispheres were elongated, it had established olfactory bulbs, and a significant cerebellum and flocculi. These were among other, less pronounced, structures such as anterior colliculi. Because of these features, it has been suggested that its brain had well-developed visual, auditory, motor, and body sensory systems. And, as a whole, the brain of ectoninian indicates that it was in the process of developing endothermy. Trucidocynodon was a carnivorous cynodont closely related to ectoninian, from the Upper Triassic Esquigualasto Formation of Argentina. It differed from other ectoniniids in several respects, including its larger size. Trucidocynodon is considered one of the largest known carnivorous cynodonts from the Triassic, as well as one of the largest Probainognathians in the entire. A biomechanical study has argued that Trucidocynodon not only had erect limbs, but that it also possibly had digitigrade forelimbs, being among the first synapsids to show adaptations for cursoriality. However, it was likely not a specialized runner, unlike ungulates and some other modern cursorial mammals. Oligokyphus were small tritylodontids with a skull length of up to 10 cm and an estimated body mass of 3.4 kg, with possible sexual dimorphism in size. The teeth of the upper and lower jaw had bump rows that fit together perfectly for an accurate bite, and Oligokyphus had a face similar to modern mammals but with differences in the cheekbones and eye sockets. The jaw was double-jointed and the neck was flexible, with an atlas and axis and a double occipital condyle. It had no canine teeth and unusually large, rodent-like incisors, with a large diastema separating the cheek teeth from the incisors. The lower postcanines of Oligokyphus had 2 rows with 3 cusps each, allowing for a well-fitting bite that was particularly good at shredding fiber-rich plant material. If a living tritylodon were to be seen today, it would resemble a large rodent, with a length of about 30 centimeters. They had a grinding motion for chewing food, with bottom teeth that had cusps and top teeth with matching grooves. They had large incisors at the front of their mouth, separated by a gap from the rest of the teeth, and their legs were directly beneath their body like mammals. Tritylodons were likely primarily herbivorous, using their incisors to dig and unearth buried plants. They were warm-blooded, and like most non-placental mammaliamorphs, it had epipubic bones, aiding in its erect gait but preventing the expansion of the abdomen, making it unable to go through prolonged pregnancy and instead give birth to larval young like modern marsupials and monotremes. Baenotherium is an extinct genus of cynodonts from the early Jurassic of China discovered by Bien Mainian. Despite its size, it is closely related to Lufengia, and is the largest tritylodont from the Lufeng Formation in China. It had 4 incisors, no canines, and back molar-like teeth, which it used to chew tough plant material. Baenotherium is defined as being big and robust compared to other tritylodonts, and also by exposed maxillaries in the skull, an unusually long diastema and thin zygomatic bone. Iragotherium hernandezii is a species known only by a humerus, a femur, 2 jaws and an upper arch incomplete, has the upper canine teeth after pills across and the postmandibular canines with a more developed central cusp, followed by 3 smaller ones. It was collected in the Candelaria Formation in the municipality of Faccional do Soterno in the Parana Basin of southeastern Brazil. The exact line between highly mammal-like cynodonts and actual mammals is very blurry. The transition was gradual and the fossil record is incomplete, and even the definition of mammal varies depending on who you ask. The earliest ancestral mammaliaforms would have looked something like Attilobacillus, a transitional form from the late Triassic of Texas. About 10 to 15 centimeters long, it was probably a shrew-like insectivore and may have been close to the start of the hypothetical nocturnal bottleneck in mammal evolution, a point where mammal ancestors are thought to have taken up nighttime activity patterns to avoid competition and predation from early dinosaurs. Features of the postcranium indicate that Brachyllodon was a generalized animal capable of diverse modes of locomotion, including digging and climbing. The large tuberosity near the deltopectoral crest of the humerus implies that the teres major muscle was quite large, as seen in modern fossorial rodents. The digging adaptations of Brachyllodon were however less pronounced than in modern fossorial mammals, as well as many other non-mammalian cynodonts. Evidence for scansorial abilities includes the hemispherical humeral and femoral heads, which would have allowed a wide range of rotation of the shoulder and hip joints, the well-developed ectepicondylar crest, the hemispherical capitulum and nearly circular radial head, which would have conferred high mobility to the elbow, and the small anconial process of the ulna. Megazostrodon was a small, shrew-like animal between 10 and 12 centimeters long which probably ate insects and small reptiles. It is thought to have been nocturnal as it had a larger brain than earlier cynodonts and the enlarged areas of its brain were found to be those that process sounds and smells. This was probably in order to avoid being in competition with the reptiles or becoming prey to the dinosaurs. Although considered a close relative of mammals, it did have some non-mammalian characteristics inherited from its predecessors. The first 2 vertebrae were still unfused as in earlier cynodonts, and it only had 3 sacral vertebrae instead of the usual mammalian 5. An interclavicle is also present, which is still present in monotremes but lost in the line leading to the in mammals. Morganeucodon was a small, plantigrade animal with a moderately long tail and a skull length of 2 to 3 centimeters. It likely had fur and specialized glands for grooming, and was nocturnal and burrowing. Its diet consisted of insects and other small animals, with a preference for hard prey, and it grew quickly to adult size. Morganeucodon had deciduous teeth that were replaced by permanent teeth, and its molars had raised humps and edges for efficient chewing. However, its metabolism was slower than that of modern mammals and it had a lifespan more similar to reptiles.